All right, so section 2.3 is called Properties of the Trigonometric Functions. Today's date is the 5th? So in this section, you guys will learn about the period of trig functions, determine the signs of the trig functions in a given quadrant, find the values of all the trig functions using fundamental identities. So when we get to chapter 3, we're going to dive much deeper into identities. But the ones that we're learning about today, I need you guys to start learning those because it will make your life easier in chapter 3, just trust me. Find the exact values of the trig functions of an angle given a quadrant in one of the functions, and then use even and odd properties. So these aren't very hard, but what I'm going to highlight here, guys, are the things that I really need you guys to know from this section when we're done. Okay? Period, you guys will learn about what period is for trig functions. The identities, you guys have a big box that you guys have in your cutouts, so pay attention to those when we talk about them. And then even and odd. There will be test questions about even and odd functions, and they're really easy if you guys just know what they are, okay? All right, so the first thing we're gonna talk about is what is a periodic function for our class. And this is a really important idea because if you guys were here on Monday, I told you guys like the next 3 sections after this, what are we gonna be doing? Graphing. Okay, so if you guys know something about period, this will make the graphing stuff easier. So right now we're just going to talk about sine and cosine. In general, for any angle in standard position, if we add or subtract integer multiples, I'm highlighting this because integer is an important thing to know, of 2 pi to an angle theta, the sine and cosine values will be the same for the new angle. We already kind of know that because what was that called, guys, when you add or subtract 2 pi to an angle and it stays the same? Starts with a C, coterminal. So if you guys know that, then this is something that is just an extra way to say it. Sine and cosine is periodic, okay? And this will make more sense when we go to graph these things. So in general, the sine of some angle theta plus 2 pi times k is the same thing as just sine of theta. If I take an angle and take that angle and add a multiple of 2 pi, either positive or negative, the sine value is going to be the same. And we could say the same thing for cosine. The cosine of theta plus 2 pi k is just equal to cosine, where the letter k is just any integer. So what would be a really basic angle to pick? Even more basic than that. 0. So if you guys have been studying, because some of you guys told me you guys were studying yesterday, what is the sine of 0? 0. Okay, so what this is saying is, what if I take this angle and add 2 pi? What's 0 plus 2 pi? You guys agree that's just 2 pi? So if the sine of 0 is 0, pay attention, guys. If I take that angle and add 2 pi to it, the answer is going to be the same. So it's just 0. What if I add 2 pi to 2 pi? What's 2 pi plus 2 pi? 4 pi. Guess what the sine of 4 pi is? 0. Guess what the sine of 6 pi is? 0. What the sine of 16 pi is? 0. That's really important that you guys understand that. Okay? All right. So these are the periodic properties. I would definitely put like little stars or highlight or whatever you guys need to do. Put a sticky note, something in your notebook so that way you guys know where to find this. So in general, a periodic function f is described where there's a positive number p such that whenever theta is in the domain of f of theta plus p is equal to just f of theta. So what this is going to tell you guys is what is the period of all 6 trig functions, okay? Do you guys agree that we already know 2 of them? What's the period of sine? 2 pi. So the sine of theta plus 2 pi is just equal to the sine of theta. This will make more sense when we graph. A period means how long it takes for the graph to repeat itself. Because you guys will learn in the next section that the sine function, watch my laser, it looks something like this. It repeats, it's a wave, okay? So the period tells you how long it takes for the graph to start over again. Cosine is the same thing. Cosine's also 2 pi. What's really helpful is we know that sine and cosine both have reciprocals, right? What's the reciprocal of sine called? Cosecant. So the cosecant, the period of cosecant is the same. It's also 2 pi. And then the reciprocal of cosine, the period is also 2 pi because cosine is 2 pi. Okay, so that's nice. So if you guys are studying for the trig functions, it's 2 pi. Nice. Which ones have we not talked about yet? Tangent and cotangent. So they're very similar in the fact that if you know tangent, you know cotangent. So tangent is not the same thing. The period of tangent is pi. Not 2 pi, just pi. So I'm going to highlight it in different colors so you guys remember that it's different. So that means that the cotangent is also pi. So these graphs we'll talk about starting hopefully Friday. And then we'll continue it next week. But yeah, I don't want to scare you guys. We'll talk about it next week. Okay, questions on these properties? Okay, so let's do some problems. So example 1. All right. So use periodic properties to find the exact values of I want us to find the sine of 17 pi over 4. So question, we just talked about this. What's the period of sine? 2 pi, right? So what I have to figure out is This angle obviously is not on my unit circle, right? It's a bigger angle than what's on my unit circle. So what do I have to add to 2 pi to get to here? So the way that I could break this up is this number right here is the same thing as the sine of what? 2 pi plus another 2 pi. What's 2 pi plus 2 pi? 4 pi plus what? Pi over 4. How'd you get that? Good. Yes. Good. Guys, these are fractions. 2 pi, do you guys agree, is the same thing as 8 pi over 4? Does that make sense? And then 2 pi again is the same thing as 8 pi over 4. What's 8 pi over 4 plus another 8 pi over 4? How many pi over 4s do I have? 16 plus another one. 16 plus 1 gives me 17. Okay? So it's just basically breaking it up until you get to the angle that you want. Okay? So, in other words, we know the period is 2 pi. So if I take 2 pi and add another 2 pi, it's going to be the same answer. So what this really is, it's pi over 4. The sine of pi over 4 is going to give me the same value. Because these two angles are 4 pi away from each other. So using our unit circle, what is the sine of pi over 4? Yes, square root 2 over 2. Okay. If that was confusing, do you guys agree I could just take this angle and just keep subtracting 2 pi? You also could have done that. So 17 pi over 4 minus 2 pi. This is the same thing as 8 pi over 4, so that would have gave me 9 pi over 4. And if I subtract 2 pi again, I get pi over 4. So because this angle and this angle are the same, we're going to get the same answer. Okay. B, let's find the cosine of negative 5 pi. Is negative 5 pi on my unit circle? No. Okay, so what do we know about period of cosine? It's 2 pi. So what I could do is, do you guys agree I could take this number and keep adding 2 pi until I get something that's on my unit circle? Okay. So if I take negative 5 pi and add 2 pi, that's going to give me negative 3 pi. And then if I take negative 3 pi and add 2 pi, that'll give me negative pi. Almost there. Negative pi plus another 2 pi is going to give me pi. Is everybody cool with that idea, where that came from? So because this angle is a multiple of 2 pi away from this angle, that means that this is going to be the same thing as the cosine of pi. So according to our unit circle, what is the cosine of pi? Negative 1. All right. C. Okay, what is the period of tangent, guys? Pi. So this angle is too big, so if I keep subtracting pi, then I can find an angle that will help me figure out what this is. So if I subtract pi, to get a common denominator, I can multiply top and bottom by 4. So then that would give me 9 pi over 4. That's still too big. So I'm going to subtract pi again. So multiply top and bottom by 4. And that gives me 5 pi over 4. Is 5 pi over 4 on my unit circle? Okay. What is the tangent of 5 pi over 4? What is it? 1. Good. Okay. Questions? Okay, cool. All right, here comes something very, 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 very important. So we're gonna learn about a little story of our trig functions. Okay, so I want you guys to write this down. If this annoys you guys, I don't care. Because I'm the type of teacher, like I was always, when I was a kid, we're always just told the thing and I never knew where it came from. I like to show you guys where things come from. So that way it's a little bit more special. Okay, so just bear with me so I can show you guys where this comes from. So depending on which quadrant a point lies, we have an easy way to remember the correct sign, S-I-G-N, not S-I-N, sign of all 6 trig functions. So for this, we have to remember that the cosine of theta is the same thing as x, and the sine of theta is y. Okay, so I'm going to show you guys all 4 quadrants and what's happening in each quadrant. So if this is some point on our unit circle, so I didn't draw it, but just pretend like we have the unit circle. I'm going to call the radius 1. This is some point x comma y. So this point right here is x, and this side right here is y. And then this is going to be theta. So according to our definitions, we know that the sine of theta is the same thing as y. The cosine of theta is the same thing as x. So class, because of where we are on the coordinate plane, what do we know about x and y in this quadrant? They're both positive. So we know that y is positive and x is positive. So if we're trying to find tangent, we know that the tangent of theta is what, guys? You guys remember? Y over x. If I take a positive number and divide it by another positive number, that means that tangent will also be positive. Okay, so what is one takeaway that we can say about this quadrant? Everything's positive, right? So quadrant 1, all trig functions are positive. So what we're going to do is we're going to go quadrant by quadrant and see what happens as we travel around, what changes. So if we go in quadrant 2, I want you guys to draw a triangle the exact same way. So guys, if we're in quadrant 2, what do we know about the sine of theta? We know it's y, right? If we're in quadrant 2, is this point right here, I went up, right? To get to there. So is sine positive or negative if I went up? Positive. Cosine of theta is x. What is x in quadrant 2? Negative. So that means that the tangent of theta is still y over x. If I take a positive and divide it by a negative, what's a positive divided by negative? Negative. Okay, so in quadrant 2, what can we say? Which one's positive? Sine. So the sine of theta is positive. So if you guys are with me right now, that means that if we remember that sine of theta is positive, then just that means that the other ones are negative. Okay? If you just remember this, that means that cosine and tangent are negative. Okay, quadrant 3. What is y in quadrant 3? Negative. What's cosine in quadrant 3? Negative. So what does that mean about tangent in quadrant 3? It's positive. So our takeaway for quadrant 3, is tangent of theta is positive. So if we're following this pattern, you guys want to make a prediction about quadrant 4? Cosine's positive. Yeah, so let's prove it. So here, sine of theta is y, and it's negative. Cosine of theta is x, and x is positive here. Tangent of theta is y over x, and since the signs are different, it's going to be negative. So our takeaway here is in quadrant 4. That cosine of theta is positive. Okay. Is everyone cool here? Are you guys following this? Does this make sense? Okay. What I want you guys to do is make a note so that way you guys aren't confused. What I'm trying to show you guys is just remember this. Because if you remember this, what's the reciprocal of sine? Cosecant. So if sine's positive, that means that so is cosecant. Okay? If tangent is positive here, so is cotangent. If cosine's positive here, that means so is secant, okay? But the thing I'm going to show you guys right now is you just have to remember about sine, cosine, tangent, and then you're good. Okay, so in summary, if we have our 4 quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4, anything that's in quadrant 1 is a positive, comma, a positive. So the takeaway from quadrant 1 is that all trig functions are positive. The takeaway from quadrant 2 was what? Sine of theta is positive. The takeaway from quadrant 3 was what? Tangent is positive. And the takeaway from quadrant 4 is a cosine is positive. Okay? So, I've seen other teachers use this before, and my teacher used this, and this helped me out so much. The way that you guys are going to remember this is a little phrase. Okay? So the way that you guys are going to remember this is quadrant 1, we know that all are positive, right? I want you guys to think about the letter A. Sine is positive here, S. Tangent is positive, T. Cosine is positive here, C. So there's a phrase that my teacher, way back when, I'm not going to say what year because you're going to make fun of me, when I was a senior, and it's this phrase. All students take calculus. All students take calculus. If you guys remember that phrase, that will help you guys with the signs of all the trig functions. Okay? Cool? All right. So now that we know that, let's do some problems. Hey guys, I really like these problems. So that should be a hint about something very important. You guys will definitely see something like this on your, there's going to be 2 quizzes for chapter 2. The second chapter 2 quiz you guys have, for sure there'll be a question like this. Your chapter 2 tests, there for sure will be a question like this. And when you guys take your final 3 months from now, there'll be a question like this. Okay, because this really shows me that you guys understand about the trigonometric functions and where they are. Okay, so we just learned our special catchphrase, right? All students take calculus. Whenever you guys see a problem like this is what I want you guys to do, is I want you guys to draw a coordinate plane like this. Okay? And then we know all students take calculus. We have to figure out, by doing this, it helps us figure out, we need to draw a triangle here. Where do I draw my triangle? This information helps you to figure out which quadrant to draw my triangle, okay? So it's almost like a process of elimination. So this is what I want you guys to do, and hopefully when you guys take your tests and quizzes, I see you guys do this as well, because it helps you guys figure things out. So it says that the sine of theta is 2/3. Not a trick question, is that positive or negative? Positive. So let's start in quadrant 1. Can sine be positive in quadrant 1? Yes. Can sine be positive in quadrant 2? Yes, because S. Okay? Can sine be positive in quadrant 3? No. So what I'm going to do is I'm going to put a big X to remind myself not to draw my triangle there. Can sine be positive in quadrant 4? No. Because cosine's positive there. Okay? So we also have a second piece of information. It says that tangent is what? If it's less than 0, that means it's what? Negative. So can tangent be negative here? No. So that means that we're in which quadrant then? Second quadrant. Okay, so whenever you guys have these type of problems, that was weird, huh? Whenever we have these type of problems, this piece of information will eliminate 2 quadrants. This piece of information will eliminate one of the last 2 quadrants. So you always know which one to be in, okay? So that means we're in quadrant 2. Okay? So then that means I'm going to draw a triangle in quadrant 2. Okay, so students last year, they would do everything correctly up until this point. So theta is always the angle closest to the origin. Your right angle is going to be this angle that is perpendicular to the x-axis, okay? And then sine is what over what? Opposite over hypotenuse. So theta is here, that means opposite of this is going to be 2. Your hypotenuse is going to be 3. I need to solve for that side. So 2, 3, and then You can call this like A, B, or C. It doesn't matter. But technically, what side is this if I'm going this way? X. I'm going to use a different color so you guys can see it. Okay? So x squared plus y squared is equal to r squared to solve for that side. So x squared plus 2 squared is equal to 3 squared. So x squared plus 4 is equal to 9, which means x squared is equal to 5, which means x is equal to plus or minus the square root of 5. Okay, so very important, guys. What do we know about x in this quadrant? It's negative. That's why this is important too, because when you guys write your answers, we know that which one of these should only be positive? Sine, which means when you guys write your answers for cosine and tangent, they must be negative because only sine is positive over here. So that's important that you guys label this side as the negative answer from that problem. Okay, so x is negative square root 5. Okay. Is everybody okay so far? Am I going too fast? No? You guys did these last year in Math 3, right? The only difference was you guys didn't know about all students take calculus? Okay. All right. So cosine, now that we know this, cosine is what over what? Adjacent over hypotenuse. So cosine is going to be the negative root 5 over 3. So cosine of theta is equal to adjacent over hypotenuse. So it's going to be negative root 5 over 3. Tangent of theta, is opposite over adjacent. So it's going to be 2 over negative root 5. Can we leave our answer like that? Nope. So rationalize. So multiply top and bottom by the radical. And we get 2 root 5 over 5, but don't forget it's negative. Cool? Questions? All right, let's do one more. It's a little bit different. B. So this is one I might give you guys to try to catch you guys off guard. Make sure you guys are paying attention. Okay, we know something about all students take calculus about all sine, cosine, tangent, right? But this doesn't give me any of those. It gives me cotangent. So what I would do first is think about what I know about cotangent. It's a reciprocal of tangent. So this is just there to throw you off. But you guys agree I could take this number and just flip it upside down, okay, to get tangent. And then since I know that tangent's negative, that's going to help me start my problem. Okay, so I'm going to draw my little coordinate grid. Label my quadrants. So this piece of information tells me that the tangent of theta is really what? -2. So because tangent is negative, Can I draw my can I draw my triangle in quadrant 1? No. Can I draw my triangle in quadrant 2? Yes. Could I draw my triangle in quadrant 3? No. Can I draw my triangle in quadrant 4? Yes. Okay. Now, using the second piece of information, cosine is positive. Can cosine be positive here? No. Which means we're in quadrant 4. So I'm going to draw a right triangle. Now, since we're in quadrant 4, I need to label my sides using the fact that tangent is -2. Remember, tangent is opposite over adjacent. So if it helps you guys, can't I just put this on at once to help me label my sides? So tangent is opposite over adjacent. So because it's negative, I'm not going to label these negative yet, because I have to make my side. Since I'm in this quadrant, guys, which one of these has to be negative, X or Y? Y, okay? So that means that this is -2 over here. So in these problems, this will help you label two sides. I always will have to find a third side. So I have to do Pythagorean theorem again. So x squared plus y squared is equal to r squared. So 1 squared plus -2 squared is r squared. What's -2 squared? 4. So that gives me 5. Square root both sides. I didn't even notice that. You get the same answer as the last problem. But that won't always happen, of course. Now, since this is the radius, right, of the triangle, the hypotenuse should always be positive. Okay? Only one of your legs of your triangle can be negative. That just depends on where you are. Okay? So, this one's actually kind of nice. Since we know that this is root 5, they want us to find secant. So before you guys do anything, if you guys don't remember that the sides for secant, we know that secant is a reciprocal of what? Cosine. So do you guys agree that cosine would be 1 over root 5? Does that make sense? Now, if you're thinking, oh man, now I have to rationalize that. Do I really have to rationalize that? No, because aren't I finding the reciprocal? So if secant is 1 over root 5, or sorry, cosine is 1 over root 5, if I flip that upside down, I'll get secant. Okay, does that make sense? I'm trying to save you guys time and stress and extra work. If you guys just write that on your test, I know where that came from. Okay, cosecant is going to be the reciprocal of what? Sine. So sine is opposite over hypotenuse, but since I'm doing the reciprocal, it's going to be hypotenuse over opposite. So it's going to be negative root 5. So next thing we're going to talk about are some of the important identities that we need for this lesson. So for you guys, an identity is an equation that is true for any variable on both sides of the equal sign. Specifically, a trigonometric identity is an identity that just has trig functions. The following are important identities to know. And when I say that they're important to know, I really mean that you guys have to know these. You have to know these. Like, make flashcards, write them down everywhere. I don't care. You just need to know these. You guys already know 6 of them without knowing you guys know 6 of them. Because for sine of theta and cosecant of theta, what do we know about the relationship between those two? They're reciprocals. So the way that we can write this is sine of theta is the same thing as 1 over cosecant of theta. This notation means reciprocal. Okay? So same thing, cosecant would be 1 over what? Sine of theta. And we can do the same thing for the other two. So cosine and cosecant, they're reciprocals. Tangent and cotangent, they're reciprocals. So I could say that the cosine of theta is the same thing as 1 over the secant of theta. And then the secant of theta is the same thing as 1 over cosine of theta. Tangent of theta is then 1 over the cotangent of theta. And cotangent of theta is the same thing as 1 over the tangent of theta. All right, quotient identity. So this one's new. Quotient means to divide. So we know that on the coordinate plane, what was tangent? Y over x. Since tangent is y over x, we know that y was the same thing as sine, and x was the same thing as cosine. So tangent of theta is the same thing as sine of theta over cosine of theta. I need you guys to highlight this one because you guys must know this one. We're not highlighting these ones because I hope by now you guys already know these. Okay? And if you guys don't yet, don't tell me, it'll make me sad. All right. If you know this one, you know this one. Because tangent is a reciprocal of cotangent. So if these are reciprocals of each other, that means that cotangent is going to be equal to, if I take this fraction and just flip it upside down. So cotangent, we can say, is the same thing as cosine over sine. Okay? Now, these are the 3 that you guys absolutely have to know. If you know the first one, you'll be able to figure out the other 2. So, the first one that I need you guys to know. Sine, and this is going to be written kind of weird. I'll explain it here in a second. Sine squared, like that, of theta. Notice that the power is not here. Okay? I didn't make up the rules. I just teach. This is just the way it's written. I didn't make up the rules. Sine squared of theta plus cosine squared of theta is equal to 1. Please highlight this one. Now, if you guys are wondering why it's written like that, I don't know. But this really just means the sine of theta squared. It's just, for trig, that's just how we write it. I don't know why. It always has bothered me since I was in high school, and it's just, that's how you write it. I don't know. I just work here, guys. Okay. So, the other 2. I'm going to just tell you guys what they are, and then I'll show you guys where they come from. So if we know this one, then the other 2 are pretty straightforward, and you guys will see why. 1 plus tangent squared theta is equal to secant squared theta. And then 1 plus cotangent squared theta is equal to cosecant squared theta. Now, when we get to chapter 3, you guys will learn something that's going to be your absolute favorite thing ever. And it's basically proving these things. And they're hard. Trust me when I say that by that point, it's section 3.4. By that point of our class, there's no excuses. You have to know these. So if you guys learn them now, it'll make your lives so much easier. Just trust me, take my advice, because last year my college kids were stressing about this. If you memorize these now, it'll make your lives so much easier. Just trust me. Okay? So can we remember this one? This one's not that hard to remember, right? Just sine squared plus cosine squared is 1. Just remember that. If you know this one, you know these two. So let me show you guys where they come from. If I write it again, sine squared theta plus cosine squared theta is equal to 1. So let me show you guys where this one comes from. If I just take every term here and just for fun, what if I divided every one of these by cosine squared? All right. So we have an identity about sine over cosine, right? What was sine over cosine? Tangent. So you guys see how what we wrote down, there's no powers? It's just tangent is sine over cosine. Sine squared over cosine squared, they're the same thing. They're the same power. So this would be tangent squared of theta. Sine over cosine is tangent. So sine squared over cosine squared is tangent squared. If this was sine cubed over cosine cubed, it'd be tangent cubed. Okay, that's just where it comes from. What would this be? If you take something and divide it by itself, what does that become? 1. And then 1 over cosine, that's one of our identities. It's secant, okay? The only difference is it's squared. So 1 over cosine is secant. So 1 over cosine squared is secant squared of theta. So this is identity 2. So this is identity 2. This, we just proved it. Okay, so that's where that comes from. No one ever showed me that, ever. So I was stressing when I was in high school trying to memorize all 3 of these. I had no idea that's where it came from. And when I was prepping for PreCal last year, that was honestly like the first time I actually realized that's where it came from. And I was like mind blown. I was like, whoa, that's so cool. I'm going to show my kids that. Okay, same thing. I'm not going to show you guys because hopefully you guys trust me. To get this one, to get the second one, do you guys agree we divided everything by cosine? To get this one, I would divide everything by sine squared. If I divided every term here by sine squared and simplified, that's where this one comes from. Okay? I'll show you guys this again in chapter 3 because right now you guys probably don't care because we won't use it all the time. But in chapter 3, if you're struggling to remember this one, I'll show you guys where it comes from again. Okay? All right. So now that we know that, next problem. So you guys are in my college class. If the directions say to use identities, that means I do not want you guys to draw a triangle. I want you guys to use the identities. So, given that the sine of theta is equal to square root 5 over 5, and cosine of theta is equal to 2 square root 5 over 5, use trig identities to find the remaining 4 trig functions. So for these problems, I don't really care like where you start. Just somewhere on your page, you just make sure you show your work for all four, finding all four. But the way my brain works is I know sine, I know cosine, so logically, what should I find next? Tangent, okay? How do I find tangent if I know sine and cosine? Sine over cosine, right? Don't we have an identity that says that tangent of theta is equal to sine of theta over cosine of theta? On a test quiz, and I'm recording this so you guys can see it again if you guys need to. On a test or quiz, please show this step. Please don't just jump straight into the numbers, okay? So, because that tells me that you guys know the identities. So this equals, what is the sine of theta? So square root 5 over 5 divided by 2 square root 5 over 5. How do we divide fractions? Multiply by the reciprocal. So this becomes square root 5 over 5 times, 5 over 2 radical 5. So to make my life easier, I'm going to cross cancel. So the root 5s, I have a root 5 on top, root 5 on the bottom, so those cancel. I have a 5 on top and a 5 on the bottom, so that cancels. So what's left on top? A 1. What's left on the bottom? A 2. So it's just 1/2. So you guys think differently than me, obviously. What could we find next? There's no wrong answer. Someone just tell me something to find next.
Cotangent.
Cotangent? Why would cotangent be really easy to find?
Just because there's no radicals to be messed with.
Yeah, so there's no radicals, and then what? How do you find cotangent if you know tangent?
It's reciprocal.
It's reciprocal, right? What would be the reciprocal of this? 2. So cotangent of theta is the reciprocal of tangent. So it's just 2. Done. All right, the other ones are a little annoying. And that's only because we have square roots. Cosecant is a reciprocal of sine. So I'm going to take my fraction for sine and flip it upside down. Which means I just need to rationalize. So I'm going to multiply top and bottom by square root 5. Which is going to give me 5 radical 5 over 5. Please reduce if you can. So I notice there's a 5 on top and a 5 on the bottom. So those cancel. So my final answer is just square root 5. All right, secant is a reciprocal of cosine. So it's going to be 5 over 2 square root 5. Now, make your lives easier, guys. What is causing us issues on the bottom, the 2 or the radical? The radical. You don't have to multiply by the top and bottom by the 2. You just need to multiply top and bottom by the radical to get rid of the radical. So this becomes 5 square root 5 over. Now pay attention. These types of problems, you will not be allowed a calculator on a test. What's root 5 times root 5? 5. What's 5 times 2? 10. Okay. Now 5 over 10, does that reduce? 2. 1 over 2. So this becomes 1 root 5, which is just root 5, over 2. Okay. Questions on this problem? All right. Now we're going to do one that's so easy. It's really weird. And you guys have homework questions like this. And hopefully you guys actually kind of like these because they're weird. But so is this class. Trig is weird. All right. So no calculator. So if you're wondering, how do I find the tangent of 20 degrees without a calculator? Well, what I want you guys to notice is all three expressions, you guys notice they're all 20 degrees. Okay? So I noticed that it's the sine of 20 degrees divided by the cosine of 20 degrees. So think about this like our theta. What's sine of theta divided by cosine of theta? Tangent of theta. So the sine of 20 degrees over the cosine of 20 degrees is the same thing as the tangent of 20 degrees. I don't know what this is, but if I take the thing and subtract by the same thing, what's my answer? 0. That's why these are weird, but they're actually kind of cool. Later on in this class, you guys will learn how to find something like this. The exact value using your calculator. Or sorry, by hand. And then we can check it with a calculator. But that's the end of chapter 3. B. Sine squared of pi over 12 plus 1 over the secant squared of pi over 12. So one thing that I noticed that's going to help us out is this. They're the same angle, right? What identity do we have for secant squared? Specifically 1 over secant. Cosine. So 1 over 1 over secant squared of something is just going to be cosine squared of the same angle. Okay? Whatever the power is, it's just going to match. So if this was cubed, then that means that would be cosine cubed. Does that make sense, guys? Okay. I just want to make sure you guys aren't confused. So how could I rewrite this then if I know this? Yes, so it'd be sine squared of pi over 12 plus, this is going to become cosine squared of pi over 12. Now, these are the same angle, right? So this is like our theta. So sine squared theta plus cosine squared theta is 1. Okay. Next problem. So what we're going to do right now, we did a problem like this doing all students take calculus. I want to show you guys how we can do something like this by using our identities. Okay, so you guys could do a triangle for this problem, but let's practice using our identities. So given that the sine of theta is 1/3 and cosine of theta is less than 0, find the exact value of the other 5 trig functions using identities. So if we look back, I think it was example 2. If we look back at example 2, what was the first thing that we did when we were given information like this?
Draw a graph, figure out which quadrant.
Yeah, draw a graph so we can figure out which quadrant we're in, right? So I'm going to draw an X and Y quadrant like this. My teacher was really nice and showed us this cool little trick. Shout out to him. He's still teaching. He's not that old. I saw that. He's not that old. Sine we know is what? Positive. So could we be here? Could we be here? Here? Or here? So I'm going to draw 2 big X's so we know not to draw our picture there. What is this saying about cosine? Cosine is negative. Can cosine be negative in quadrant 1? Can cosine be negative in quadrant 2? Yes. So I'm going to put an X here. And we're not drawing a triangle because we're practicing using our identities because your professor wants you guys to help you guys learn them. That's me. So I'm going to draw a smiley face. That means we're in quadrant 2. Okay, so since we know this, okay, make sure that when you guys are doing your answers that you pay attention to this picture when we're doing all of them, okay? So to show you guys the thought process of how to do these, if I know sine, do I have any identities that tie together sine and cosine and only sine and cosine? So a lot of students say this when I ask that question. They'll say, well, I know tangent is sine over cosine. Do I know tangent yet? So I can't use that yet. Which identity ties together sine and cosine? Yeah, sine squared plus cosine squared is equal to 1. So if I use that identity, I can solve for cosine. Okay? So to find cosine of theta, we can use sine squared theta plus cosine squared theta is equal to 1. So sine squared is the same thing as sine, parentheses, squared. What was sine? 1/3. So this would be 1/3 squared plus cosine squared is equal to 1. To square a fraction, square the top, square the bottom. What's 1 squared? 1. 3 squared? 9. Okay. This is a college class. This is the same thing as 9 over 9, if I'm getting a common denominator. 9 over 9 minus 1/9 is 8 over 9. Okay. This is the same thing as cosine of something squared. So to get just cosine, I can square root both sides. Now, You can do a tree on this. What does this break down to? Do you guys know? Yeah, 2 square root 2. And what's the square root of 9? 3. So cosine is going to be 2 root 2 over 3. But what do we know about cosine? It's negative. So don't forget that part, guys. Okay. So order doesn't matter on how to find these. I'm going to do tangent next just because then the other 3 are really easy to find. Tangent, we know, I already said it, and we practiced it already, is sine over cosine. So the sine of theta was 1/3. Cosine of theta was 2 root 2 over 3. And look at me being silly, I forgot my negative. Okay. Multiply by the reciprocal. So it's going to be 1/3 times negative 3 over 2 root 2. 3's cancel. So we get negative 1 over 2 root 2. Which number on the bottom is giving us trouble? The radical 2, right? So multiply top and bottom by radical 2. And we get negative root 2 over 4. Okay, is everybody okay? Not too bad. So the other 3 are pretty easy to find, right? Let's start with cosecant. Cosecant we know is the reciprocal of sine. So what is that? 3. Secant of theta is the reciprocal of cosine. Good job, guys. So it's negative 3 over 2 root 2. Multiply top and bottom by the square root of 2. And we're going to get negative 3 root 2 over 2 root 2 times 2. If I simplify, it's going to give me 4. All right, cotangent, we can use a little trick that I showed you guys. If I flip this upside down, I'll have a radical and I'll have to do all the math again. But do you guys agree that this and this are the same thing? I rationalize this in order to get this answer. So that means that the reciprocal of tangent is the same thing as if I just take this and flip it upside down. So if I flip this upside down, I just get negative 2 root 2. Okay. So understand though, you guys could have drawn a triangle and it'd be the same thing. You'd get the same answers, okay? I just want you guys to practice using your identities. All right, questions? All right, cool. I'm gonna skip this because I don't want to burn you guys out. Last thing, even and odd. So I want to tell you guys so that way you guys don't think I'm a hot mess express, even though it kind of looked like it last week when you guys took your test. That first problem you guys had on your test, the definitions, remember I told you guys not to do it? It's because last year I did give them like 10 on their test, and quickly before I printed it, I was trying to make it easier for you guys, and I was trying to delete questions. But when I deleted it, I didn't realize that it was also deleting the definitions, the answer choices. So there's missing answer choices, so that's why I told you guys not to do it. So I was trying to help you guys out, and it backfired. So You guys don't have to worry about those being graded when I grade your tests. But the reason why I thought about this is because if you guys remember the even and odd functions, that's why I brought that up again. Because if you remember them, then it actually makes our life easier for what we're about to do. So remember, a function is even when f of negative x is equal to what? F of x, good. And then it's odd if f of negative x is equal to negative f of x, okay? So, if you know cosine, then guess what? You know secant, because they're reciprocals. The cosecant function is even. I don't know what's happening over there. My computer is like, there's a ghost. It like, sometimes when I go over there, windows will be open, things will be clicked on. I don't know what's happening over there. My room is haunted. Cosine and secant are even. So that means that the cosine of negative x is just equal to cosine x. And the secant of negative x is equal to secant of x. Cool. All right. So this is where things are going to get really easy. If you know cosine, just trust me, that means that the reciprocal behaves the same way. Can you close stuff? Just everything. Sorry. Does that make sense, guys? So if you remember cosine is even, that means that everything else is odd. You guys trust me? You guys listening? Sorry. So which trig functions have we not talked about yet? Sine. That means that cosecant is also odd. Thank you. And then tangent and cotangent. So in other words, since they're odd, that means that the sine of negative x is negative sine of x. And the cosecant of negative x is equal to negative cosecant of x. The tangent of negative x is negative tangent of x. And the cotangent of negative x is equal to negative cotangent of x.